In the second of our shadow videos, we will work through the exercise from the Barcelona packet. Find the drawing that looks like this and tape it down to your drafting board. Make sure it's properly aligned. You can use either the verticals or the 30-degree angle as your guide to get it aligned to the board and taped down properly. Once it's taped down, our first step is to identify the visible shade lines. Remember, in plan oblique, we assume that the altitude of our light source is 45 degrees above horizontal, and the azimuth of our light source is horizontal to the board, 30 degrees or 60 degrees to our drawing. We can have the light go either to the left or to the right. In this case, we're going to cast our shadow to the right. Based on that, these are our shade lines. The top is always lit, and because we're casting the shadows to the right surface will be in shade. When we have repeating elements, such as the columns, they will have the same pattern. We just need to determine what's going to be the shade line on one, and then it will occur on all three. The next step is to identify the hidden shade lines. Remember that the shade line is the edge between a lit surface and a shaded surface, and that our lit surfaces and shaded surfaces all exist in pairs. Top is lit, bottom is unlit. Left is lit, right is unlit. Because of that, our shade lines also occur in pairs and that will be diagonally opposite each other. To construct the hidden lines, we need to use some internal geometry. Use your understanding of plan obliques to find those hidden corners. We're going to use our 30 and 60 degree triangle to draw these lines to get those hidden locations. I've indicated our hidden shade lines with the dashed line. Now we have all of the elements that we need to be able to draw the shadow on the ground and any shadows from these lines that may occur on surfaces of the object itself. To construct the shape of the shadow, we're going to construct the shadow following the shade line. We're going to start with a shade line that is vertical and touches the surface that our shadow will land on. So in this case, we're going to start with the shadow of the vertical line on the front bottom corner. We know that the shadow of a vertical line on a horizontal surface will be parallel to our azimuth. So in this case, it will be horizontal. We know that it ends based on the altitude of our light source. So in this case, we're going to take a 45-degree angle through the opposite end of that line and see where it intersects the shadow on the ground. That gives us the starting point for the shadow of our next shade line, in this case, the top horizontal edge of the beam. It is a horizontal element, horizontal line in reality, so its shadow will be parallel to the line. In this case, that means it will be on a 30-degree angle. Again, we know where it will end based on the altitude, the 45-degree angle. Now, these altitude lines that I've indicated in yellow will never be part of your shade outline, your shadow shape. Okay? So it's important to differentiate them. I'm drawing all of my lines completely to help you visualize them, but if I was going through this exercise myself, I would just make tick marks for those intersections to avoid future confusion. The next shade line is the very short line on the end of the beam. That's on a 60-degree angle, so we will draw a line on a 60-degree angle. Again, we'll use our diagonal, our altitude, to determine where it ends. The final shape or final line of our shadow shape on the ground initially is the shadow of the hidden shade line on the back side of our far column. We know that it is going to be parallel to the shadow that we started with because the line casting it is parallel to the line we started with. In this case, that means it will be horizontal, right? And it disappears behind the back of the column, but we can see it would meet the bottom of that shade line. Now we need to complete the shadow of the internal aspects of the shape. Again, we have a series of vertical lines for the columns. We have both the visible and hidden shade lines, and we can draw all of those as horizontals. To determine where they end, we can take any of our shade lines that are intersecting the hidden edge of the beam and use our altitude to get the length. That is the end of the shadow for the vertical, but it is also an intersection for the shadow of the horizontal edge of the beam. We know because it is a horizontal surface, and the shadow is on a horizontal surface, the shadow will be parallel to the line, and thus it will be on a 30-degree angle. This completes the outline of the shadow on the ground. And we're almost done, but there is a small shadow that is cast on the sides of the columns by the edge of the beam. To construct that shadow, we're going to have to do a fair amount of work. First, we're going to take an imaginary line that intersects the far edge of the beam, the underside of the beam, and we're going to determine where it would reach the ground. You can pick any point along the beam to work from. We construct the imaginary line that would be in line with that edge on the ground to determine where that line would reach the ground. We want to determine how that shadow would be cast across the ground and then up the plane of the column. I realize this is kind of confusing, hard to think about, and perhaps not something that you would imagine on your own. But hopefully when we're done, you'll understand the process. I then take my altitude line to see where the shadow of the beam would land on the plane that would be the far side of the column face. So now I have another shadow point of the beam, but now where it would land on the internal structure. Still, that plane is parallel with the opposite face, parallel with the line of the beam. So the shadow will be parallel to that line of the beam as well. Again, it will be on the 30-degree angle. Where it intersects the columns are points on the shadow that is cast on the side of the column. I know that the point where the column touches the beam is another point that will be common to the shadow. So I can connect those dots and get this little triangular shape that now completes the shadow of this figure. And that's it. Remember, when you're doing shadows, we don't build from shadows. You want to get the big ideas and get the key elements. One of the things to notice is that the shape of the shadows is wider than the elements themselves. It may be wider, it may sometimes be thinner. It depends on the geometry of our drawing relative to the geometry of our light source. But it is not just a two-dimensional representation of the form. It is a three-dimensional. It represents the three-dimensional form coming off of diagonally opposite corners.